Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be looking at the Samsung VIK range of video recorders from 1993. Now this particular model, this was a real headache for Samsung. I think it's probably one of the models that they were better forgetting about, and the reason for that was not long after the warranty period expired, these suffered from a catastrophic failure, which must have cost Samsung an awful lot of money. Now Samsung back then, they were a pretty decent company and they did the right thing. They produced repair kits and spares for this, and they sent them all out to the dealers free of charge, because it was a combination of poor design and poor circuit layout. So let's just take the top off and we'll take a quick look. So there we go, we'll take a quick look round, and I'll run you through it as we go. That's the power supply in the metal box. That's where all the trouble originated from. So there's an IC down there. I think that was a loading motor drive. That used to burn out. There were quite a few of these Zener diodes on the main board. They used to overheat and all this board would all be burnt and crispy, and you'd have to change the whole new board. I've fitted loads of them in the past. The capstan motor here, that would actually burn out. What else was there? On the clock display here, there was a 27 volt Zener diode behind here. That would overheat and that would burn all the board, and you'd have to put a whole new clock board in. And all these things all happened at the same time. It wasn't just one part failed or another part failed. Everything happened at the same time, and the reason for that will become apparent in a second. So first, let's just take a look at one of the kits that Samsung issued to try to repair this. Now I've still got quite a few of these left over, so let's get one of these bags open and let's just have a quick look through it. That's the bits what's in the kit. Now some of these parts actually repair the power supply. That's the chopper control and the power supply, and some other bits repair the main board. And the procedure was, you fitted this kit and then you see what other further damage there was. You might still end up replacing the main board or the clock board, but there was enough parts in here to actually get the power supply going and to do limited repairs on the main board. So let's take a look now at the instructions it comes with. Now, interestingly enough, and this is what's so laughable, Samsung actually called the chassis of the video the 6 Winner 1. Well, this was no winner for Samsung. We take a look at the first page here. We've got power supply failure. That's because this usually ended up with a power supply self-destructing. That's the loading motor IC. That will be the diode I mentioned that used to burn the timer panel. Yeah, it says there, if there's a diode faulty, then the capstan motor's got to be changed as well. So scrolling down here, switch mode power supply, replace any capacitors that may have exploded. They didn't come with a kit, you only got one with a kit. The one you got with the kit was C110, and we'll come back to that after. Turn over the page here, we'll just scroll down really quickly. Now it comes to the bottom here, it says if the switch mode power supply fails any of these tests, it should be discarded and a replacement fitted. Well, funny enough, the power supply was always repairable. I never had any trouble with them. They worked first time. I've never even replaced a power supply in one of these. So if we look over here now, main PCB, visually check the PCB to determine the extent of the damage. If the board was badly burnt, because these very fine tracks on it, and when you started lifting diodes out, it would all disintegrate. So then, if it failed that test, then you had to swap the whole PCB. That is the 27 volt diode I mentioned on the clock panel. That could also damage the board. More parts in the loading motor drive, capstan motor. And let's turn over to the last page, and this just gives you some basic instructions on checking things. So now I think what we'll do is we'll take a look at the service manual, and I'll show you what was the big problem with the design of this unit that led to this failure. So if we take a look at the IC that the power supply uses, this in my opinion is where Samsung got this so wrong. This is the data sheet for the STR11006, and if you look at this, this is just a reference design. If you look at that, it's absolutely identical to the primary on this. Even the component numbers and the values are absolutely the same. Now this is just a reference design. You're not supposed to build just from this. You're supposed to use this as a building block to design your own power supply. So if we examine the secondary of the power supply, this is one of the first problems. You will see that there's no optocoupler, there's no closed loop feedback from the output to the input. Now what you'd normally do is you'd normally do the main HT rail, which is 6.5. You'd usually have some sort of divider reference feeding an optocoupler, and that would be feeding information from the the secondary back to the primary. Now in this circuit, this IC has no idea what voltages are on the secondary, and what they omitted to do is they omitted to fit the feedback optocoupler. That was one of the big mistakes. So if we now look at the primary, you'll see a negative bias is generated by this auxiliary rail, and it's generated across that capacitor there. Now this capacitor, this is what sets the output voltage. The primary, the secondary, the primary has no idea what voltage on the secondary. It's all set by that capacitor, which makes that capacitor absolutely critical. And if you look at that, Samsung have labelled it up 105 degree, so they knew that that was a critical part in the circuit. So the negative bias going into pin 1, that sets the output, but this chip doesn't know what voltages are on the secondary with no optocoupler. So what used to happen is that capacitor used to dry up, and all these output rails would all start rising up to a dangerous level. Now if you look, there's no over voltage protection either. The only over voltage protection is provided by that Zener diode there, a 22 volt Zener diode. Now the idea is if the potential here rose above 22, that would short out and shut the power supply down. Now bearing in mind that's 22 volts, and we move across here and we see the rail, it's only actually providing a 16.5 volt rail. So that would mean a considerable rise here before the diode even went short circuit. So that would mean the 16.5 volt rail could rise by 16 volts, could rise by another 6 volts before anything went wrong. And what happened with these diodes is they didn't go short circuit because the output was rising very, very slowly. So the diode wouldn't just go short circuit because half of these machines would be left in standby, and as that capacitor dried up more, the output rails would just keep rising and rising very gradually. So you'll see when that gets to 22 volt, it's going to start dissipating more and more heat before the diode fails. And that was the problem. All these rails rose up onto the main board and caused so much catastrophic damage. So with virtually no protection on this power supply, and the fact that Samsung knew that was a critical part in the operation of the circuit, why did that dry up? Well, I've taken the power supply out now, and we'll take a quick look at that. So that's the capacitor we want to look at there, C110, and if you look there, That is C110. You've got a 2 watt wire wound resistor underneath it, and you've got a 2 watt resistor right next to it. Now that won't be dissipating too much heat because it's actually it's the current limit, so we can only draw a certain amount of current from the power supply, but these two resistors here, 33 ohms, these are dissipating considerable power, and one is right next to that capacitor and the other one above it. So that's the one that's sat right next to the capacitor, and that's the one that above it, and it's for this reason that dried out so quickly. It was the positioning of that capacitor which Samsung knew was a critical part of the operation. Now actually in the kit itself, for that capacitor, Samsung used to supply a little bit bigger one. I think that's rated at 25 volt. I wouldn't be surprised if that's a 16 volt, but I never used to fit this. What I used to do is I used to buy capacitors from Farnell's that instead of rated at 105 degrees, I used to buy ones that were rated at 125 degrees, because there's not many other places you can move that capacitor to, and even if you moved it to the top, you've still got the heat rising up. So I never ever fitted these. I only fitted a 125 degree one. Now I was told this video was working, so we're going to power it up, and if you look at the state of the tin plating there compared to the underneath, I would imagine this probably stood in somebody's loft for a considerable amount of time, so it might not have had a lot of use despite its dusty appearance. But I'm going to take that capacitor out, and we're just going to change that, and then we'll have a go at powering it up. But yeah, that is the problem there. They put that in the hottest part of the circuit. Now, interestingly enough, on top of this capacitor, let's see if we can get it, there's like some sort of rubber jacket been stuck over the top. I wonder if that was some sort of a heat shield. So we're going to flip it out of there, and then we'll test this capacitor. And also there's another capacitor there with like a rubber thing on the top. Whether that's some sort of, perhaps they thought sticking that on would stop it getting hot, but I might just change that one and the startup capacitor as well, change all three, and then we'll power it. But let's just see if we can slip the jacket off that and see what's underneath. Right, well that capacitor is definitely not good. It's got a series impedance of just over 15 ohms. So it's a good job that we didn't just plug this machine in. I mean, obviously if this was stood in standby and it was warm, that impedance would be a lot lower than that. In fact, what we can do is we can just warm it up with a hairdryer and see why we've got a different reading there. Right, let's just warm that with a hairdryer and see what happens. That you'll probably find that the impedance will drop and it'll be alright again. Right, so just warm that up with the hairdryer. Let's test it again. Yeah, see the series impedance is falling and the capacitance is rising. Right, so that's the plastic jacket removed from the capacitor. You can see it's what is it, 100 mic 25 volts, very small, and that's the one that Samsung supplied in the kit, 100 mic 25 volt. So yeah, I can only assume they put that on to shield it from the heat, which turned out actually to be a total waste of time. Right, well that's capacitor C109 out as well. Also I pulled off the plastic jacket on that, and we're going to put that back on the new one to keep the originality. Just slip that onto there like that, and then just one more capacitor, and we'll plug this in and see if we manage to save it. And last but not least, I've changed the startup capacitor there, C122. Right, so I'm going to power this up now. Yeah, let's come on. And before I try taping it though, we'll just try this test tape and just make sure everything's working. Right, where's the play button? Play. Yeah, we've got take up. And I'll just press eject and make sure we got... Yeah, we've got rewind, so it should be okay to just put a tape in that now. Right, well, unfortunately, it's not actually working because we've only got the output from one video head. Now, it could be that it just needs cleaning, or it could be a problem with the head, but we're going to have to put this to one side now till I get some lint-free cloth to clean the video head. Anyway, that's the job for another day. I'm not too concerned about this at the moment. I've just stuck the top on for now. This video was just about the power supply failure and the shortcomings in the design. Alright guys and girls on YouTube, many thanks for watching my channel, and I'll catch you in the next one. Goodbye.